Welcome to Math with Mr. J.
In this video, I'm going to cover the order of operations. This is going to be a complete introductory guide, and really, if you're looking for a review, this will work for you as well. We will start with why we use the order of operations. We will then go through some basic examples and how to use the order of operations. Then we will take a look at some examples that involve parentheses and exponents. So these examples will be a little more difficult. And then we will end with examples that involve a fraction bar. So let's start with why we use the order of operations. Remember, the order of operations are parentheses, exponents, multiplication and division, and then addition and subtraction, PEMDAS. Now, simply put, we use the order of operations. That way, everyone is on the same page as far as working through problems. We all work through them the same way in order to get to the same answers. And there isn't any confusion about how to work through things. We all use the same set of rules, the same set of instructions. That's the order of operations. Let's take a look at an example to show why this is important. We have 12 minus 5 times 2. Let's work through this two different ways. We will start by forgetting about the order of operations. Let's say that a person works from left to right, starting with 12 minus 5. So what's this going to look like? Well, 12 minus 5 is 7. Bring down everything we did not use, so the multiplication sign and the 2. Now we have 7 times 2, which is 14. So our final answer when we work from left to right is 14. Now let's do 12 minus 5 times 2 another way. We're going to start by doing multiplication first. So let's say this person starts with multiplication, which would be 5 times 2. So let's start there. 5 times 2 is 10. Bring down everything we did not use. So the 12 and the subtraction sign. So now we end with 12 minus 10, which is 2. So our final answer when we start with multiplication is 2. So you can see that we have two different answers, even for a simple problem like this. So imagine a more complex problem and the number of possible answers. That's why we need the order of operations, a set of rules we can all follow to get to the same answer. Now, taking a look at the order of operations, we do multiplication before subtraction. So 2 is the correct answer for this problem. Think of it like this. If everyone had their own set of rules for stoplights, we would have some issues. So if some people used red for go and green for stop, and then others used green for go and red for stop, that would definitely cause confusion. But that's not how things work. We have a set of rules to go by. That way, we are all on the same page. Now, we can also relate this to measurement. If everyone had their own idea of what a foot, a meter, or any other unit of measure was, that wouldn't work out. There would be a lot of confusion and differences. A foot, a meter, and all other units of measure are the same for everyone. That way, we can all be on the same page, and there isn't confusion from person to person. We have a standard way of doing things, a set of rules we can all go by. And that's what the order of operations is. So that's why we use the order of operations. Let's move on to some example problems and how to use the order of operations. Here are the first two examples, and remember, as far as the order of operations, we start with parentheses. So parentheses are priority number 1. If we see parentheses in an expression, we start there. Then we have exponents, then multiplication and division. Now, I do want to mention multiplication and division are on the same level. They are the same priority in the order of operations. So if we have both, we work from left to right. and then addition and subtraction. Now, addition and subtraction are on the same level. They are the same priority. So if we have both, we work from left to right. This will all make a lot more sense as we go through our examples. Just think of the order of operations like a set of instructions that we follow step by step. Now we have an acronym that we can think of in order to remember that order. PEMDAS, so parentheses, exponents, multiplication and division, and then addition and subtraction. So PEMDAS just represents the order of operations. Let's jump into our examples and see exactly how all of this works. Starting with number 1, where we have 30 divided by, and then in parentheses, 13 minus 8. So let's work through the order of operations. Do we have any parentheses in this expression? Yes, so we start there. We have 13 minus 8 in parentheses. 13 minus 8 is 5. Then we need to bring down everything we did not use. So we have 30 and then divided by 5. So now we have 30 divided by 5. We only have one operation here, division. So that's what we need to do. 30 divided by 5 is 6. So our final answer, 6. So for number 1, we worked through the order of operations. We started with parentheses, then we brought down everything we did not use, and we ended with 30 divided by 5, which gave us 6. Let's move on to number 2, where we have 16 minus 5 times 3 plus 12. Let's work through the order of operations. Do we have any parentheses? No. So let's move on to exponents. Do we have any exponents? No. So let's move on to multiplication and division. Do we have any multiplication or division? Yes. So that's where we start. We have multiplication. We have 5 times 3. That is 15. Now we need to bring down everything we did not use. So we have 16 minus 15 and then plus 12. So we have 16 minus 15 plus 12, and we need to continue to work through the order of operations. Any parentheses? No. Any exponents? No. Any multiplication or division? No. Any addition or subtraction? Yes, we have both addition and subtraction. Since we have both addition and subtraction, we need to work from left to right. Addition and subtraction are on the same level. They are the same priority in our order of operations. So again, we need to work left to right. When working from left to right, we need to do subtraction first here. So 16 minus 15 is 1. Bring down everything we did not use, so plus 12. And now we have 1 plus 12. We only have one operation left, so that's what we need to do. We need to add. 1 plus 12 is 13. And that is our final answer. Let's move on to numbers 3 and 4. Here are numbers 3 and 4. Let's start with number 3, where we have 7 squared minus 14 times 2. Let's work through the order of operations. Are there any parentheses in this expression? No. So let's move on to exponents. Are there any exponents in this expression? Yes. So let's start there. We have 7 squared, which means 7 times 7. That's 49. Bring down everything we did not use. So now we have 49 minus 14 times 2. Let's continue to work through the order of operations. Any parentheses? No. Any exponents? No. Any multiplication or division? Yes, we have multiplication. So that's what we need to do next. We have 14 times 2, which is 28. Bring down everything we did not use. So 49 minus 28. We have one operation left, subtraction, so we need to subtract. 49 minus 28 is 21. So our final answer, 21. Let's move on to number 4, where we have 18 divided by, and then in parentheses, 6 plus 3, and parentheses times 15. Let's work through the order of operations. Any parentheses in this expression? Yes, so we need to start there. We have 6 plus 3 in parentheses, that's 9. And then we need to bring down everything we did not use. So now we have 18 divided by 9 times 15. Any parentheses? No. Any exponents? No. Any multiplication or division? Yes, we actually have both multiplication and division. Since we have both, we need to work from left to right. Multiplication and division are on the same level, so to speak. They are the same priority. So when that happens, we work from left to right. When working from left to right, division comes first. We have 18 divided by 9. So let's do that. 18 divided by 9 is 2. Bring down everything we did not use. So times 15 there. And now we have 2 times 15. 2 times 15 gives us 30. Our final answer, 30. So there are 4 introductory examples. Let's move on to some examples that involve parentheses and exponents. Here are our examples involving parentheses and exponents. Let's jump into number 1, where we have 13 plus 5, and then in parentheses, 2 cubed plus 4, end parentheses, divided by 2. Now, one thing I want to mention before we get started, whenever we have a number next to parentheses, so we have 5 and then a set of parentheses, that's multiplication. So we have 5 times whatever we get within those parentheses. So let's go through the order of operations. Are there any parentheses? Yes. So we start there. We need to do anything inside of parentheses. Well, we have 2 cubed plus 4. So we do exponents before addition. So let's do 2 cubed first. 2 cubed means 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So 2 cubed is 8. So in parentheses, we now have 8 plus 4. Now we can bring down everything we did not use. So 13 plus 5, and then in parentheses, 8 plus 4, end parentheses, and then we have divided by 2. So let's go through the order of operations. Any parentheses? Yes. So we need to do anything in parentheses here. We have 8 plus 4, which is 12. Now we can bring down everything we did not use. So we have 13 plus 5 times 12. Whenever you have a number next to parentheses, that's multiplication. So that's 5 times 12 divided by 2. So let's continue to work through this problem step by step. So any parentheses, anything within parentheses that we need to do? No. Any exponents? No. Any multiplication or division? Yes, we have both. We have multiplication and division. Multiplication and division are the same priority. So what we do, we work from left to right if we have both. So let's do 5 times 12. First, 5 times 12 is 60. Bring down everything we did not use. So 13 plus 60 divided by 2. So now we have 13 plus 60 divided by 2. Do we have any parentheses? No. Any exponents? No. Any multiplication or division? Yes, we have division, 60 divided by 2. So let's do that next. 60 divided by 2 is 30. Bring down everything we did not use. So we have 13 plus 30. All we have left is addition. So that's what we end with. 13 plus 30 gives us 43. And that is our final answer. So again, we just broke that problem down. We worked through that problem step by step, following the order of operations. Let's move on to number 2, where we have 15 minus 7 in parentheses, and that is squared, minus, in parentheses, 36 divided by 9, end parentheses, times 10. So let's work through the order of operations. Do we have any parentheses? Yes, we have two sets of parentheses. So let's work from left to right. We will start with 15 minus 7. 15 minus 7 is 8. Now we can bring down everything we did not use. So we are squaring whatever we got within those parentheses. So bring down the exponent of 2. Then we have minus, and then in parentheses, 36 divided by 9, end parentheses, times 10. So now we have 8 squared minus, and then in parentheses, 36 divided by 9, end parentheses, times 10. So let's continue to work through the order of operations. Do we have anything within parentheses? Yes, we have 36 divided by 9. So let's do that next. 36 divided by 9 is 4. Bring down everything we did not use. So 8 squared minus 4 times 10. So now 8 squared minus 4 times 10. Any parentheses? No. Any exponents? Yes. So that's what we need to do next. We have 8 squared, which means 8 times 8. 8 times 8 is 64. Now we can bring down everything we did not use. So minus 4 times 10. Now we have 64 minus 4 times 10. Any parentheses? No. Any exponents? No. Any multiplication or division? Yes. We have 4 times 10, so we need to do that next. 4 times 10 is 40. Bring down everything we did not use. So we have 64 minus 40. And we're only left with subtraction here, so this is what we end with. 64 minus 40 is 24. And that is our final answer. So there are a couple of examples where we had parentheses and exponents. Let's move on to some examples involving a fraction bar. So now we will take a look at examples involving a fraction bar. Now, when it comes to fraction bars, they tell us to group everything together on top, the numerator, and then group everything together on the bottom, the denominator. The fraction bar acts as a grouping symbol. Group the top, group the bottom, and then lastly, we divide the top by the bottom. So the numerator divided by the denominator. Let's jump into our examples and see exactly what this all means. Starting with number 1, where we have 10 plus 5 times 6 above the fraction bar, so the numerator, and then 12 divided by 3 below the fraction bar, so the denominator. So that fraction bar tells us that we take the result of the top, the numerator, and divide it by the result of the bottom, the denominator. So we can think of it like this. We are grouping the top and grouping the bottom. So group the numerator and group the denominator. Once we have those results, we divide. Now, as we work through this, we need to use the order of operations. Let's start with the top. We have 10 plus 5 times 6. So we need to multiply first and then add. Remember, multiplication comes before addition. 5 times 6 gives us 30. So we have 10 plus 30. That gives us 40. So the numerator is 40. As far as the bottom, we have 12 divided by 3, which is 4. So the denominator is 4. And we end up with 40 over 4. Now we need to divide. We have our numerator, 40, divided by our denominator, 4. 40 divided by 4 gives us 10. So this is our final answer, 10. Now, before we move on to number 2, I do want to mention we can work through problems like this that involve a fraction bar to the side. So let me rewrite the problem here and go through what this will look like. So 10 plus 5 times 6. And then we have the fraction bar, and then 12 divided by 3. So let's start with the top. We need to multiply first. 5 times 6 is 30, so 10 plus 30 gives us 40. And then as far as the bottom, 12 divided by 3 gives us 4. So we end up with 40 over 4. So 40 divided by 4 now gives us that answer of 10. So just a different way to work through the problem. We get the same answer either way, but if you prefer working your way down, or maybe you prefer working your way to the side, either way will work. Let's move on to number 2. So now we can take a look at number 2, where we have 28 minus 22 plus 15 on top. And then below the fraction bar, we have in parentheses 27 minus 9 end parentheses divided by, and then in parentheses 3 times 2 end parentheses. Let's start with the top. So we have subtraction and addition, which are on the same level. They are the same priority. That means we work from left to right. So working from left to right, we have subtraction first here. So 28 minus 22. That gives us 6. Then we have plus 15. So 6 plus 15, that gives us 21. So 21 is the numerator. Now let's take a look at the bottom, so the denominator here. And we have two sets of parentheses. So we have 27 minus 9 and 3 times 2. For the bottom, we're going to work through this in a couple of steps, since this has a little more to it. Let's work through the parentheses. So we have 27 minus 9, that gives us 18, divided by, and then in the other set of parentheses, we have 3 times 2. That gives us 6. So we have 21 for the numerator. And then as far as the denominator, the bottom, let's do 18 divided by 6. That gives us 3. So we end up with 21 over 3. 21 divided by 3. That gives us 7. And this is our final answer. Let's work through this problem to the side as well to show what that will look like. So we have 28 minus 22 plus 15. Then we have the fraction bar, 27 minus 9 in parentheses, divided by 3 times 2 in parentheses. Let's start with the top. So we have 28 minus 22. That gives us 6. Plus 15 gives us 21. Now for the bottom, and we will do each set of parentheses. We will start with 27 minus 9. That gives us 18. Divided by, and then the other set of parentheses, 3 times 2, gives us 6. So we have 21 over, and then 18 divided by 6 is 3. And we end with 21 divided by 3, which gives us a final answer of 7. And again, it doesn't matter which way you go about working through these problems. You can work your way down, or you can work your way to the side. Either way will work as long as you follow the order of operations. And just remember, that fraction bar is a grouping symbol. We group the top, and then we group the bottom, and then lastly, we divide the results. So the result of the top divided by the result of the bottom. The numerator divided by the denominator. So there you have it. There's an introductory guide to the order of operations. I hope that helped. Thanks so much for watching. Until next time, peace.